Hello, this is Arben Kalziqi with the Wolfram U team here at Wolfram Research, and this is a quick demo of our new Wolfram AI Assistant. Before we show any examples, the first thing I'd like to let you know is how to actually access the AI Assistant. Well, in version 15, we have a new little icon at the bottom here. You may already see an expanded bar, but if you don't, you can just click this icon, you'll see a bar, and you can just start typing in your query right there. Wow, a query. You can change the default settings of how this bar should appear in your notebooks. You can have it kind of minimized by default, open, or just straight up hidden. Up to you. Other than that, if you'd like to get this sidebar interface, you can do that just by going to Help and clicking AI Assistant Chat. And you'll see that there's a keyboard shortcut specific to your particular localization and keyboard layout and OS and all that stuff right there. And lastly, the easiest way maybe to get started talking to AI Assistant at any time and any place is you can just type an apostrophe and it'll open up a brand new chat cell right there for you to type in. With that in mind, let's try out some examples. The first thing to say is that AI Assistant is not just an LLM, but that it knows about all of the documentation and resource functions and other resources that are bundled in the kind of Wolfram knowledge base, Wolfram ecosystem. It has access to all of that, and it can write and run its own Wolfram language code. So when you ask it to do something, it's not just generating a response strictly from an LLM, but it has access to all this extra information. So let's start with some questions about maybe coding. Maybe I'm totally new to coding, I'm in Wolfram language, and I want to see how do I do things. I think I will actually use the sidebar, just so we can kind of keep it a little bit neater. But here I'll ask, how could I find the largest element in a nested array? In Wolfram language, it would be called a nested list, but remember, I'm new to Wolfram language. I don't know anything about the names, so I'll call it a nested array. I just press enter. It's generating me a little response here. It says we can use max if we want the value itself, and we can see that this is a nested array. So we can just click insert and evaluate here, and notice that this nested array isn't even rectangular. Yuck. But we can click insert and evaluate. It'll put it right in the notebook for us, and we can evaluate it and get an answer and see that max works even on a nested array. We don't need to specify anything else except for max and then the array here. And if we want to find its position, it says we could use the position function here. So if the array that we had before were saved to the value array or to the symbol array is 38, 112, 5, 7, we could just use position and it would tell us where it is. So it's in the second part of the second part. And then it also gets us some extra information to say, well, if you wanted to access the second part of the second part, the way you do that is with these double square brackets. So let's check to make sure that we get it. And indeed, it's correct. And maybe there are multiple positions, so it gives us some extra information still about how to get just the first position if that max appears multiple times. So pretty helpful, and it offers some other ideas here about what we might be interested in based on that query. Let's try another one. Maybe I want to, how could I sort a table by its third column? Maybe I got some nested list, and in the third column there are some elements, and I want to sort the whole table by those third elements. So here it says we can use the sort by, assuming the table is a list of rows, which I think is a good assumption. We could use the sort by function and then extract the third element using this kind of maybe strange construction if you're not familiar with it. This is a pure function or a lambda function, but we can test this out and see how it works. So let's take this example table here and see, all right, we got this, and we're going to sort it by its third element, 3, 1, 2. So we should have 1, 2, 3 at the end. And indeed, there it is. And then it even tells us maybe we want it in a different order. Here we can have reverse sort by. So let's try that out. And we can see that that works in the opposite order. Then it gives us some other possibilities. If maybe we don't have a nested list, maybe we have a tabular object. And something else that I do want to note here about the responses from AI Assistant are that these are full links to the documentation, so you can click them. Of course, for me, it's opened on a secondary monitor here, but you can click them and it will open up the documentation. Once you have this, you can kind of look into these things yourself. So it's not just that you're getting answers from AI Assistant, but it's also providing you with the tools that you can use to help learn on your own. So you can go to Tabular and say, oh, what's a tabular? How do I use this? You can read through here, check out all these different simple examples, go into the scope and see a bunch of more in-depth information. You can see all the different options that are allowed for tabulars, different applications, relations to other symbols and functions in the language. And even here, you can see that there are a bunch of related functions. And this is really useful to help you kind of build up your mental vocabulary of the different functions in the language. So even if the AI assistant doesn't produce something that is helpful to you right away, it almost always is going to, at the very least, link you to some documentation that can help you get to where you want to go. Let's try a bit of a different one. So let's say this one's going to have a little formatting tinge to it. Show me a few different ways to make a list where all of the prime numbers are framed. Now, this is kind of a useful trick, right? If you ask for multiple ways to do something, you can kind of start to grasp the shape of the possibilities of what you can do here. So maybe you want to use, well, it's given us a bunch of different possibilities here. So we could use a table with an if statement. So it's very direct. You test each integer with prime q, and then you wrap primes with framed. Okay, let's just insert and evaluate that. Check it out. Yep, seems to work. Here's a different way of doing it with map. So if it's prime, if the input is prime, frame it. Otherwise, just return it on its own. That does work. Oh, we could use replace. That's kind of a Wolfram AI way to do it, a pattern matching replacement rule. That works too. Or we could use map at by extracting the positions of the primes. And you can really start to get yourself situated when you see all these different ways of doing the same thing. You can kind of pick out which way you like. Maybe you want something concise or something that's very easy to read. Maybe something that works, it's extensible in a certain direction. That's cute. Maybe you just want to have only primes in the list, and then you can frame all of them. And then we have some extra notes here, again, linking us to some useful functions. Something else that I want to note about AI Assistant is that it's not just aware of, the Wolfram documentation and all the resources that we have available. It's also aware of everything in your notebook and everything in the chat history, of course. So what if I had some code? And let me copy and paste this code over. And again, let's say I'm totally new to Wolfram language, and I don't really know all the ins and outs in functional programming. Let's say I've got this horrible list here, and let's take a look at what the horrible list looks like by using matrix form. Which, if you didn't know, of course, you could ask AI Assistant, how do I visualize this as a matrix or a table? And it would tell you. So it's this 3 by 5 by 4 list. Okay, so it's a nested list where it's like a matrix where each entry of the matrix is itself a vector. And let's say I've got a function f, and I would like to apply f to each of these integers here. And I don't really know how to do it. Like I said, I don't know anything about functional programming yet. So I write a bunch of nested loops here. I make an empty list of the same dimensionality of my horrible list. And then I do this nested looping, for looping, where I make up some dummy variables, I, j, and k, to count out the kind of distances in each dimension here. And then I iterate all of them. And then once I've done each of the iterations of these 3 loops, I set the new element to be f of the old element. And what I get is, well, it does work. But, maybe I have a sense that that's not the best way to do it. I've heard that loops tend to be less efficient and concise in Wolfram language. Is there a better way to do this using functional programming? And hopefully we can get some help here, because you really don't want to be writing loops like this in Wolfram language if you can avoid it. Okay, it's still generating. It does like to generate a lot of text. That is what LLMs are kind of built for, and so that's just what they do. So here we get an explanation. You usually prefer whole expression and functional operations over explicit for loops. That is true. So if you're going to do this, just use map at the right level. So given something like the 3D array that we have, we could just say map at level 3. So let's test this out and see if it works. Well, it looks like it worked. Let's go ahead and put a matrix form here so we can do a one-to-one comparison. Oh, it's the exact same thing, and all we had to do was map F onto my horrible list at level 3. And then it gives us some other possibilities here. Maybe you could, do a replacement rule if that's your thing. But the first way is faster, that's true. And then we get some explanations about this. And this won't quite work, but it actually is telling us why it won't work there and how it's subtly different from what we actually got. And it gives us a comparison. So like I said, it knows about what we have there and can use that to inform its responses. So it's a direct comparison saying, you had this, but now look at this. Isn't that better? And then it gives us some other useful functions that we might be interested in. So we could check out the documentation for map if it's not clear how it works from this example. Maybe look at nest and fixed point, things like this. Fold is a good one, and so on, right? And let's say, we could ask one more question about this before moving on. Let's say that F is sine. Is there an easier way to do this operation? Maybe? And I'm cheating a little bit. I know that there's a better way, but let's check if AI Assistant knows. If F is sine, it's generating a bunch of response here, but let's scroll back to the top because I liked what I was seeing. If F is sine, there's an even simpler way because many numeric functions are listable. Indeed, sine automatically threads over lists, so we actually, if F had been sine, we could have just written sine of my horrible list, and it would just do that automatically. We wouldn't even have to map. So instead of mapping, we could just directly do it. And note here, it doesn't just mention the word listable. It says sine, and again, that's a linked function to the documentation, and has the attribute listable, which means it automatically applies itself to each element of a list or array, and gives us some examples of how that works. So let's click those, and indeed we see that is how it works, which is pretty nice. And that's a good rule of thumb. There are a lot of built-in functions that are listable, particularly a lot of these kind of fundamental numeric functions. And indeed, we can check that with attributes. So we see here that it has listable, and we could check something else like, you might expect if sine is listable, probably like tangent is listable, and indeed it is. All right, let's change gears a little bit. Do just a little image analysis example. Let's move over here. Let's say I've got this picture of my lovely Dumbo boy Michi. We're going to evaluate this. And by the way, if you're totally new to Wolfram language and Wolfram notebooks, you can see that you can actually just paste images or drag and drop them right from your computer or the web right into a notebook. And once they're in here, they're as computable as anything else. So maybe I'd like to do some basic image editing. Let's say, how could I make my boy into a black and white image? It says we can binarize it. That would make it black and white, certainly. Maybe that's not exactly what we meant by black and white, but it is literally black and white. And then here, it says converted to grayscale explicitly, then binarize, which I don't think that does anything if we're working in a grayscale color space. But let's say this isn't what I wanted and I'm not happy with the rest of these responses. I can complain, so to speak. I can say, I meant black and white more like old movies or pictures, not literally only black and white. Well, let's see what it says. So for that, we do want to use color convert, which we might have been able to figure out from this being here, but we might as well complain about the answer and then see if we can get something direct. So insert and evaluate. Indeed, there we go. And just because I can't help myself, let's say, Um, let's go back to the color version. How could I swap the red and blue channels? Show me 2 ways to do it. So again, it can be helpful, pedagogically speaking, to ask for multiple ways to do something so you start to understand what the possibilities are when you're writing your own code. So first, we could color combine, a color-separated version where we reorder things. 3, 2, 1, so it was 1, 2, 3, but we swapped 1 and 3, and those would be the R and B channels as requested. So here we go. We've made blue Michi. Scary, frankly. Or use a neural net layer that reverses the channel order. Sequence reverse layer. That could work. Yeah. With a little bit of resizing, because neural networks do a little bit of this. This is not what I would have expected, but it's very funny that it works. And this kind of gets into a whole thing with Wolfram language has full support for neural nets. It has symbolic layers that you can write with all these kinds of input and output encoders and decoders that you can use. There are many possible things, and this is taking advantage of the fact that swapping RGB to BGR is just reversing the color channels. So this is a funny way to do this. There are other ways that are simpler, but that's a cute response, I think. All right, let's try something, again, totally different. Maybe something with geography. Let's say, how could I make a map of the 3D terrain around a mountain? Use Mount Everest as an example. A good built-in way is to use geo-elevation data. That much is true. So let's see. We got data, geo-elevation data, Mount Everest with a particular geo-range and an automatic geo-projection, and then we're going to plug that data into listplot3D. I happen to know that there's a reverse there because of that's just the typical way the topographic data is displayed versus the kind of array form when you plot it. Just something to do with latitude and longitude. And then mesh functions, number 3. Ooh, I'll explain that. Let's try it out. And there we go. We got it. Just one little prompt, and we're able to get this lovely 3D plot. And what this mesh functions number 3 is doing is, instead of looking at, say, the first and second variables, so to speak, in this 3D data, the 2 ones that are in plane, it's making a mesh function out of only the third one, that is the height. So when you look at it from above, you can see that where the lines are really close together, we have a steep change in the height. And when they're rather far apart, that's where we have a flatter region. So this is kind of standard for a topographic map. So that's some good contextual knowledge that the LLM has brought in here. Another thing I'd like to mention is that this elevation data, this isn't pulled from the web. This isn't generated by the LLM. The LLM knew that Wolfram language has a function that has hand-curated, geo-elevation data of the whole surface of the world, more or less, that we can use in order to get this plot and have it be computationally correct. So this isn't, it can't be hallucinated, and it's not just pulled from the web. This is, real data that we at Wolfram have access to, and the LLM has access to it as well. And it says, well, we could get a different terrain by doing this or that. Maybe we could try this, just give it a shot. This makes a region. What's funny about regions, this is kind of pointless in this context, but just for the sake of it, we can integrate, say, the function x squared plus 2y minus yz, where x, y, z are elements of this volumetric region. YZ elements of invalid integration variable or limits. Is that the case? Maybe this is only a boundary region and it's embedded in 3 space. Typically this would work. I'm not sure why it doesn't here. Let me check to see if this is a region. Oh, it's a graphics 3D. I see. So because this is a graphics 3D, it didn't work. But if this were a region, we could integrate over it. Like I said, kind of beyond the scope of this little demo, but you could ask to get a region instead of a graphics 3D version of this, and you'd get something that you could integrate over and 3D print and all that jazz. Okay, we also have access to, say, sociological data. So we could say something like, make me a map of Asia where all of the countries are colored by their total populations. And here we get a very direct way to do this with georegion value plot using our entity framework, which again is pulling real hand-curated data by folks here at Wolfram, not pulling from the web, not being generated by the LLM. The code is generated by the LLM, but the actual data is real data that we here at Wolfram have access to. And there we go. And it gives us some variance here. This will be redundant because Geo region value plot always produces a plot legend automatically, unless you turn it off. But hey, it's good that it's thinking about that. And here this is with a different color function, so we could think, oh, there are different color functions. I happen to know there are a bunch of different ones. But of course, you could ask the assistant about those as well, if you had a color function in mind. You could even ask it how to define a custom color function if you like. Let's again try something different just to kind of show off the breadth of what's possible here. Total change of pace. Plot the first 5 eigenfunctions of the quantum, if I could type it, I'm not on my usual keyboard, of the quantum harmonic oscillator. Let's see if it can do this. Okay, we can do this from the closed form harmonic oscillator wave functions using, well, this fellow was French, but in America, I'm sad to say that we pronounce his name Hermite. So we can use these Hermite polynomials this way. Can write the wave functions that way, and it just happens to have those. Let's see. Yep, those look good to me, and it's set all the physical constants just to 1 there. So those are the eigenfunctions, and those correspond to these quantum numbers. That's true. And the eigenvalues, yes, at least in units where, h bar, omega are just set to 1. Yep, the standard half integers. And, I've done this before. You can even ask it to compute these by using D eigensystem, which stands for differential eigensystem. And again, it's a link. So you can click it and you can read about exactly how this works. So I think it's pretty nice that it was able to do that. Let's do something a little more directly chemistry related, maybe. Make me a plot of density versus atomic mass. I want atomic mass. Let's go atomic number. That's much more reasonable for what I'm trying to do here. Make me a plot of density versus atomic number for all of the elements of the periodic table. Please add labels for each element's name in the tooltips. We can't see the plot there. Let's see if it works if we insert and evaluate it. So it didn't work. Let's see. This plot is empty. I'm not even going to look at what's wrong with it. I'm just going to say, what's up with that? This does look overly complicated to me, this code for this. Let's see. Yep, that works. It's not really how I would go about this, but I can't argue with the results. I think we've got our densities, atomic numbers, and we can see here, we got in the tooltips, it's very small, but you can see all the names of the elements as we just mouse over. And pedagogically speaking, say you're in a chemistry class, this is really nice because this conveys immediately that as you go across the rows of the periodic table, it's periodic for a reason, right? You can see 1, 2, 3, 4. You can just go across and see how these parameters vary. And it doesn't necessarily have to be density. It could be something else. But we could see that these parameters vary, not say linearly, but periodically. So that's pretty neat. And I've got just one more example that I'd like to test out. This one will be about creating and even deploying a little simple web interface. So let's say publish a web form ending in molecule structure plot. Let me put that in parentheses, where someone can type in the name of a chemical and get back a plot of its molecular structure. So we're combining kind of a lot of different little areas of knowledge here. How do we make a form? How do we publish the form to the web? How do we interpret somebody's natural language input as a real chemical or molecule? And then how do we take that and create an actual, real plot of the structure from it? Let's see. It seems to have gotten hung up, I think. Maybe it's still generating more code. Strange. I can genuinely say I haven't seen this happen before. And if it's running into problems, I'll just ask for the form and then we can ask how to deploy it. So let's try this. Okay, here's our website, and let's try caffeine. Wow, there it is. Okay, let's see, dopamine. 2 highly related molecules in my experience. There's that. Let's just say water. There's that. And yeah, so you could type any sort of thing in here. I should have thought of a really complicated molecule to test out. Let's in fact, what's an example of a particularly complicated molecule? And I don't feel bad asking a question like that to an LLM because my focus was in physics, so I'm always focused on simpler stuff. I don't know about all these complex, scary chemistry things. Paclitaxel, sure. Let's see if it can do this. Paclitaxel. Whew. All right. But even with that little hiccup there, it was just 2 prompts, and one of them was just try again to get this thing to write code and deploy a website that could do all this just like that. So I hope that this quick little demo has given you some ideas about how you can just open up a notebook, open up AI Assistant, and get started turning your rough ideas into real computation. And maybe the best thing about this that I forgot to mention is that if you have version 15 of Mathematica, Wolfram 1, Finance Platform, or a site license to any of those things, you have basic AI access and thus AI Assistant included. So you can just open up the notebook and get started with turning your rough ideas into computation. All right, have a lovely rest of your day. Bye-bye.